Here we summarize all of our energy principles and energy transfer principles. Of all the forms of energy we've discussed, we can roughly divide them into two broad categories here, those that fall under the banner of mechanical energy and those that fall under the banner of non-mechanical energy. Let's focus on mechanical energy first. This dwarf icon here with his little beard is going to represent a force for us with a subscript C. That's a conservative force. Conservative forces do work that takes kinetic energy and transforms it into a stored form called potential energy. And then they can do positive work to take that stored potential energy and transform it back into kinetic energy. So we get this cycle of transformation performed by certain conservative forces. And there are only two conservative forces that we've discussed. There are others that exist in nature, but the two we've discussed so far are gravity, represented by the green orb, and the elastic force, represented by the red orb here. So the mechanical energy of a system is going to be the sum of all of the kinetic energies that we include in the system, plus all of the gravitational potential energies and elastic potential energies. So the sum of the red, the green, and the blue makes up the mechanical energy. And conservative forces that are present just sort of shuffle energy between these three forms without losing any energy in the process or without transforming it into a non-mechanical form. Conservative forces keep mechanical energy cycling between these three forms: green, blue, red, the K and the U. But there are lots of other forces that exist. Every other kind of force we will categorize as non-conservative, NC there for a non-conservative force. And when non-conservative forces, hardworking non-conservative forces do work, they can transform mechanical energy into non-mechanical energy. And they can also transform non-mechanical energy into mechanical energy. They can transform one kind of non-mechanical energy into another kind of non-mechanical energy. They can really do anything. Non-mechanical or non-conservative forces can perform lots of transformations and transferences. In this non-mechanical group over here, we include chemical potential energy, nuclear potential energy, electromagnetic energy, and thermal and acoustic energy. I should also mention that thermal energy can be transferred between bodies, between systems, via a process called heat transfer, which is a subject you would study in a course on thermodynamics. So we'll have nothing further to say about it here. But heat transfer is distinct from work done by forces. These are the two main processes of energy transfer and transformation: doing work and transferring heat. Heat is for another course. That's on thermodynamics. Let's see here. Those are our energy categories. As far as our equations for energy transfer, we have the work energy theorem, which tells us that when forces do positive work, they add kinetic energy to objects, speeding objects up. When forces do negative work, they remove kinetic energy from objects, slowing the objects down. And our two conservative forces, gravity and elastic or spring, when they do work, when they do negative work, they transform kinetic energy into stored potential energy. So when potential energy increases, that's because a conservative force is doing negative work, turning kinetic into potential. That minus sign is there to remind us of the direction of that transfer. And then lastly, when we define the mechanical energy of a system, we see that it can be increased by work done by non-conservative forces. Mechanical energy can also be decreased by negative work done by non-conservative forces. Or if there is no work done by non-conservative forces, if that's zero, then the change in mechanical energy of the system is zero, and we say that the mechanical energy of the system is conserved. E would remain the same over time if there is no work done by non-conservative forces. That's the wrap up. One final note here. the way I've divided up all the kinds of energy here is not the only way to look at them, not the only way to divide them. There are many other categories and subcategories of energy that we could get into. I'll briefly mention a couple as pertain to electromagnetic energy. Electromagnetic energy includes electromagnetic radiation and also what we think of as the energy transferred by electricity. Electromagnetic radiation includes the entire electromagnetic spectrum, from high energy gamma rays down to low energy radio waves and everything in between. X-rays, ultraviolet light, visible light, infrared light, microwaves, radio waves. In a sense, these are all forms of light. Electromagnetic radiation is light. It's just that our eyes can only see a narrow portion of that spectrum, the part we call the visible light. But it's not fundamental. But visible light is not fundamentally different from these other kinds of light, the higher energy light that we cannot see and the lower energy light that we cannot see. These are all forms of electromagnetic radiation, and along with electricity, these are essentially forms of electromagnetic energy. Let's end here on our summary.